Hey everyone, Sakanya here. Today we're going to be taking a look at how to solve this integral 0 to 1 over root 2 of sine inverse x over 1 minus x squared 3 over 2 dx. And in order to solve this problem, we're going to be using integration by parts as well as u substitution. So first I want to use u substitution, and I am going to let sine inverse of x equal to theta, because I know that sine inverse of x is always going to be an angle, and I'm going to represent that angle as theta. Therefore, I know that sine of theta is equal to x, therefore dx is equal to cos theta d theta. Now I'm going to replace this expression in terms of theta instead of x. I'm going to leave the bounds just as they are. I'm going to change them later. And I know that this is equal to theta. X is going to be sine theta, so therefore we have sine squared theta. We have a 3 over 2, and I know that dx from over here is equal to cos theta d theta. Now for these bounds over here, currently these bounds are in terms of x, and I want them in terms of theta since this whole expression is in terms of theta. So I am going to do just that. I know that if x is equal to 0, and that is from over here, if x is equal to 0, I'm going to replace it in here, and I'm going to get the value of theta. So sine inverse of 0 is 0, and when x is equal to 1 over root 2, I know that sine inverse of 1 over root 2 is pi over 4. So our new bounds are going to be 0 to pi over 4. Now let's start to simplify. I know 1 minus sine squared theta is just cos squared theta. According to the laws of exponents, I can rewrite this as, because 2 times 3 over 2 is just 3, and I know that we can cancel out a cos because we have cos here and then cos cubed theta here. So our new integral is going to be theta over cos squared theta d theta. I'm going to bring this cos squared theta up, and hence we have theta secant squared theta d theta. I'm now going to apply integration by parts, so I'm going to let our first function be theta and our second function be secant squared theta. So integration by parts says a little something like this. We have our first function followed by the integral of our second function minus the integral of the derivative of our first function, which is just derivative of theta with respect to theta, which is 1, times the integration of our second function. And I'm not concerned about the bounds right now. We're going to add them a little bit later. Now I'm going to simplify this. Integration of secant squared theta d theta is just tan theta, and I know that the integration of tan theta is minus natural log of cos theta. Now I have just added the bounds, and I'm going to simplify this. And this is our final answer.